Bismillahirrahmanirrahim. Assalamualaikum. In this video, we will learn how to use compare instruction together with the branch with the condition code instruction. For our problem, we use to determine BMI for a person. Let's say BMI is body mass index. If let's say we got 6 feet tall and then with a weight of 150 pound, we got a BMI value, let's say 20, 30, 40 or 45, and from this value we can convert we can know our BMI status, either we underweight, normal, overweight, obese, or severely obese. Okay, so first thing first, we need to convert the problem into this table. Okay, from this BMI table, I convert to a question. Okay, write an assembly program to classify BMI data reading according to table 1. This is table 1. Table 1 will be given with the question. Assume that BMI data reading is available at address 2000, and output result will be stored at address 2000, and the size of BMI data is only 16 bit. Okay, here is the BMI reading, and this reading is available at address 2000, and this reading can be more than 40, 30 to 40, 25 to 29, 20 to 24, and less than 20. And this is the category or the status. If let's say the BMI for you is over 40, meaning that you are severely obese. And for me, if my BMI reading is 22 or 23, so consider my BMI is normal. Okay. For output, we want to ask micro P to categories. Let's say for severely obese, we put data F to the address 2000, If obese, data E is overweight. If overweight, it's data D, normal, and data C. And for underweight, data B will be stored at address 2000, Okay, so this is the table. Okay, what we need to do from this table, we need to come out with our flowchart. Okay, so this is the flowchart. Like I mentioned to you before, we need to start our flowchart with start. We need to begin our flowchart with start, followed by initialization, and last with end. So for each case, we need to come out with the operation. If we look to this what we call this the original problems, it start with less than 20, but for mine I rearrange the table to bigger than 40, 30 to 40, so that the flow for my program is nice and easy to write the coding. Okay, so okay, for each data I map to each process. For this one, if BMI is greater than 40, and then this is the result. If not, I compare with another value, and if the condition is true, this will be the result. But if the condition is not true, I'll scan for another possibilities until the last. Okay, so 1, 2, 3, 4, 5 process for 5 category. Okay, so start initialization. First I check BMI is greater than 40. If the condition is yes, and then I instruct the micro P to branch, okay, to branch to a new location that I label as SEV underscore OB, and do the process of store data 0F. Next, it will go, or it will jump to N. And if not, if this condition is not, if meaning that BMI is less than 40 or equal to 40, micro P will scan second possibility. That is BMI is greater than 30. If here, even though I scan for BMI is greater than 30, but in actual, we scan data between 30 to 40. Because it's bigger than 40, if the data is bigger than 40, micro P will take this branch before we have a chance to scan the second possibility. Okay, and let's say if the BMI data is 35, here micro P will take OB branch, OB branch, and store data E to store. Where store? Here at the output. Okay, and next until the end. So lastly, micro P will scan BMI is greater than 20, meaning that between the 20 to 25 is the data is matching, micro P will branch to the label norm. And if not, we can conclude that the BMI data is less than 20 or 20, okay, less than or equal to 20. So data 0B will be stored at output here. So meaning that it is under underweight category. Okay, from this flowchart, we can convert to coding. Okay, like this one. Initialization. This is initialization. Initialization. This is part for initialization. Here. Okay. For compare. Compare R1 40 and branch greater than is belong to this process. BMI is greater than 40. Branch if greater than. Here, branch if greater than, and do not branch if not greater. Okay. Okay. These two instructions is to represent this process. These two instructions, another two instructions represent this process. Here represent this process. Here represent this process, and here represent this process. But this 1, 2, 3, 4, we write the coding here because micro P already take the branch. Okay. Here, compare R1 with 40 if greater than, meaning that greater than 40. If 41, micro P will take this branch and go to SEV OB. SEV OB, I write here. So we move data F to R2, and then we store data R2 to R7, which is R7 whole address for 2010. Here, address for output. And then we branch. Branch without condition, meaning that branch here to N. Always branch to N. That's why we can't see any diamond like this here, because it is branch to branch always to N. Okay, if we didn't use branch here, if we didn't put branch here, micro P will run this line of program, and micro P will store, we override F with new data E, and then if without branch here, it will override again with D, and will override again with C. So the only last data will be stored as a result. So that's why this branch is important. Okay. Okay. Next, we transfer this coding to kill. It's our kill here. So demonstrate BCC and compare example. So this one is a table for reference. This part is to store the dummy data to address 2000. Meaning that we want to create a dummy data at the BMI storage location. And this is the program. This program is exactly like what we write here. LDR starting from here, LDR 2000 until the end. Until here. Okay? Until here. Okay. Let us assemble the program, build a file. Okay, no error. Run debug. Okay, we copy dummy data. Tap. Okay, now here is the dummy data. So I put our dummy data is 19. BMI value is 19. Okay, and then we run this 3 line of coding for initialization. Yeah, this 3 line coding for initialization. I load address for BMI data location, and I load address for storage location to R0 and R7. Okay, and now I start reading the data to R1. Here, 13 in hexa is equivalent to 19. Where's my data? Here, 19, our dummy data. This 19 is in decimal. So you can see here in hexa, it is 13. Okay, I start compare with 40. 40 in hexa 28. Okay, I compare with 40. Branch if greater. In this case, the value is not greater because it is lower than 40. So it will not take the branch. This branch, it will run next line of instruction. I compare again with data 30. So branch if greater, again the value is not greater. I compare with 25. Branch if greater. So value 29 is of course greater than 25. So microP will take this branch and it will go to OV. This is a level OV. 1, 2, 3. Wait, compare with 25. My data is 19. Sorry, it's not 20. It's not 29. It's 19. Okay, compare again. It's not greater until the last. So last microP will store data 0B, copy data 0B to R2, and then store R2 value to R7. R7 represent output address. Okay, and then microP will skip all these routine for several obs, OB, OV to end. Okay, so finish. So let's verify our result. Data 13 or 19 in hexa, category B. Let's look to our table. Data 19, category B. Okay. Let's change our dummy value into 25. Instead of 90, I use 24. remember to rebuild the data and then rerun the debug. Okay, so we process, put dummy data, copy address, copy data, compare with 40, not match, compare with 30, not match, compare with 25, not match. Lastly, I compare with 20. 24 is greater than 20, so microP will take this norm branch. Okay, see, it will skip all other lines of instruction and then jump to norm or branch to norm. So for this norm instruction, it will copy data C to R2, and then this data C will be stored at address for output. Okay, here 0C at address 2010, address 2010, data C for value 24. Okay, okay, let's change BMI value again. This time I use 37. 37 dummy. Okay, again copy that the value dummy data to address 2000, load address, load data, compare with 40, greater than 40, no, it's not greater than 40, so microP will execute next instruction. Compare with 30, is it greater than 30? Yes, greater than 30, so microP, condition now is true, condition now true for this comparison, and then we microP will take this branch, okay, to OB, copy data E, and then branch always we skip to here. Okay, so let's verify our result. Data 35 at 37, status E. Data 37 here, status E at address 2000 0010. Okay, okay, so this is how we use BCC together with compare instruction to solve a problem. In this case, to check the BMI status for any person. So I think that's all. Thank you.